Okay, everybody, so we did 4.28 last time, right?
Yeah.
So what we're going to do is, let me go over to some of the problems, few more, before we wrap up chapter 4. You can try 4.31 also. Okay, that the question says, let me read the question for you. 4.31. A 5.6 kilogram bucket of water is accelerated upward by a cord of negligible mass whose breaking strength is 75 Newton. Alright. If the bucket starts from rest, what is the minimum time required to raise the bucket a vertical distance of 12 meters without breaking? So the force is there, all you need is the acceleration. Alright. Same like the penetration of the tree. Remember the bullet thing? Right? And the whole idea is you have F, right? And then you get the acceleration, so you will have a clue to find an acceleration.
Right? The height.
Right. Right, exactly. So I believe you can do 4.31. 4.32 also pretty much similar. 4.33, to educate a child want to push a wheel cart on the direction marked X in the page. The two adults push the push with the horizontal. Yeah, let me do 4.33. Okay, let me do 4.33 for you. So here's the. I'll start from here so that I will not cover from with my body. Okay, so let me do here 4.33. What the question says here is two adults and a child want to push a wheeled cart in the direction marked X. So there is a wheeled cart. They want to push this wheeled cart in the X direction. Alright. They want to push it in this direction. Alright. This is your X direction. So one guy is pushing this way, another guy is pushing this way. Okay. What the question says there is, one force is acting on it on this direction. I'll use another pen here. So let me use different pen. What the question says is one guy is pushing in this direction. Alright, and the angle is 30 degrees. One guy is pushing in this direction at an angle of 30 degrees. Okay? And the other guy is pushing at 60 degrees. This is 140 Newton. 140 Newton. This is your F2, the second guy. The first guy is pushing in this direction at an angle 60, but only 100 Newton. Okay? So this guy is pushing a little bit up, a little bit more angle, which is 60 degrees. Alright? But the force is little less. So force is little less. So if this is like 140, so approximately this is like 100. So your F1 is 100 Newton. Now here's the clue. If you have two forces, the resultant force, what the question says is, the resultant force is not here. Somewhere, I don't know, maybe down or maybe up. This is longer but small angle. Alright? This is a little shorter but big angle. So the total can be somewhere here or total can be somewhere here. Are you following? We don't know. But the thing is, this body will not go in X direction. So let's say it goes a little bit up, for example, somewhere here. Alright? Then, in order for this cart to go in X direction, a child, there's another role for a child. So, with a child has to push somewhere. If it goes this way, then he has to push a little bit down so that it goes this direction. Are you following? Does it make sense? Or if it goes down, then child has to push up. So most likely from this figure it looks like, since it's too big angle, so most likely it goes somewhere here. Alright? So the child has to not let it go, because this cart has to go in this direction. Are you following? So the child has to push at least with certain force. Does it make sense? Just give you an idea. So that it goes in this direction. That's what the question says. Alright? So there's another one child, tiny little child. I don't know where it goes, either downward or upward. Are you following? So all you have to do here is, first of all, find out the y component of F1. How much y it pushes, alright? How much y it goes. And find F2 also y component. And get the resultant. Alright? So you know how much portion of y movement will be there. Is that okay? Yes. What's the question? The question says, what will be the minimum force needed by this child so that this goes in x direction? That's the question. The cart with this force, with these two forces, the cart will not go in this direction. That's what it means. Are you following? So it means there is a little bit of offset in y direction. Does it make sense? So in other words, get the y component of this and get the y component of this. Are you following? So that will not be 0 total. If the total is 0, then it will go straight on x direction. Are you following? So you have to make it 0 with the help of this guy. Is that clear? So in other words, take the y component only. Alright? Take the y component only. Let me start with this blue. Let me start with the green. So when you see here F1 of get x only. Sorry, y. F1 of y only. Alright? So what will be the F1 of y? We know very well, which is what?
100 sine
100 times
60.
sine or cosine?
Sine 60.
Sine of 60. Very good. By the way, there's Newton here. We have done so many times using the units, right? So I'm not worried now. Alright? So I'm not worried now. So all I do is I'll write at the end. Alright? The unit. So you're okay. So 100 Newton times sine of 60. This will sine 60 is 1/2, right? So this will be 50. Is that right? No, sine of 60 will not be 1/2. It will be 0.8. Wait. Cosine 60 will be 1/2. So sine 60 will be 0.8. Can you do a real quick?
80.6.
80.6. Okay, very good. 80.6. Are you sure? 80.6? Really?
86.6.
86. Yeah. Yes. 86 point. I trust you.
Yeah.
I trust you. Okay. All right. This one is the y part of this force. All right. Now, if we check the y part of this guy, what is this? F2y will be what? 140 times sine. Sine what?
Sine 30.
Sine 30, but you are missing a little bit something.
Minus.
Minus 30, yes.
Yeah.
Or you can do minus here and use sine 30. It's the
okay.
same thing. Because look here, you are taking this absorption. So you can put here minus and then write down 30. Or if you are like confused, don't worry. So it will be minus 30. Actually, this minus will bring this minus front anyway. So minus 30 will be, sine minus 30 will be minus half.
Minus 70. Minus 70.
Minus half. Half of this guy will be
70.
minus 70. Very good. So what you can see here is the total is not 0 for sure.
Yeah.
Are you following?
Yeah.
Are you following? So there's another one called child. You can do it two ways. You can do it like total and then the child is like minus of that
So,
total.
let me say something.
Say it again.
Let me say something.
Okay.
If we just draw, divide it at 60 by 2, wouldn't we get the angle for that child?
No. No. Why you want to divide this 60 by 2?
No, because for the child.
No. 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 So here's the thing. In order for this box to go straight on the x direction, your total y has to be 0. Are you following? In order for this guy to go only in x direction, your total y has to be 0. So now this is your child. Your child y is, let's say, f3. All right. The child has. Oops. Let me use. The child is red, right? Okay. So your child. I write here 3. All right. This is F3. This is for child. F3 along Y has to be something. Are you following? So that the total will be 0 because it's not moving in Y direction. Are you following?
Yeah.
So now what it means is F3Y plus actually minus 70 Newton, right? And then plus this. You have to sum up total, right? Total along Y. Actually, I should write here. Total force along Y equals to, alright, total force along Y equals to this guy plus this guy is minus here, okay, and then what is it? Plus 86.6 Newton. Your total force must be 0. Are you following? Because why? Because the cart is going only on X direction. So this is the minimum force required. Are you following? By the way, the child can push in at a certain angle also, downward, but that will be more force. Are you following? Because you have to take the component of that force, right? So the lowest will be straight down. Is that clear? The lowest will be straight down. If the child pushes a little angle like this, so he has to put like a little more force. Right. Does it make sense? Okay. So, what will be this? Your F3Y will be?
70 minus
70 this, and then goes on the right, it will be negative, right?
70 minus
Are you following? So this will be minus, do the math, 16.6, right?
Yeah.
It will plus 16.6, so it will be minus 16.6. So what it means is, the child has to push vertically downward. Child has to push vertically downward. So our guess was correct, right? So we thought like this guy, without the child, will go somewhere here. That's what we were thinking, right? Are you following? Because this looks like here and this looks like here, so it will be somewhere here. So he has to push a little bit down so that it goes here. Does it make sense? So, does it ask the angle? Let me.
No, I just say if they ask.
Yeah, if they ask the angle. Yes. 16.6 Newton, right?
What's that? Without pick up with your phone.
Hold it small.
Your phone is going down. Your phone.
Okay, oops. Phone almost fell. Okay. Okay. All right. So where are we now? So what does the question say further? And the second one, if the child exerts a minimum force found in part A, so this is part A, right? This one is part A. Now the question is, with this force, now what it says? This is under the minimum force found in part A. The cart accelerates at 2 meters per second in the x direction. Okay, now with this force, with all these forces, the cart accelerates by 2 meters per second. Alright, in the x direction. So now you need to go find all the x component. Are you following?
Yeah.
Make sense? So what the question says is, with all those forces, with all three forces applied, the cart moves in x direction with the acceleration of, now the next one is what? Acceleration along x was what? 2 meters per second square.
So definitely we need the angle for the.
Say it again?
For this. We definitely need the angle.
Of course, yes. Now, yes. Yes. By the way, this angle you don't need for the child because you know child is going vertically downward, right?
So it's like 270.
270 negative. I mean plus 270 or 90 negative, whatever you call it. Are you following? So yes, the idea is good because you need the angle for that force also.
Yeah, to get that.
Right, but it's vertically downward, so what it means is 90 degree, negative 90 degree, right?
So it's like vertical.
Right, so the child has to push
Down.
downward. The child has to push downward with a small force. Alright? With a small force, which is only 16. Remember, it were 86 and then 70, right? The child is only 16. So the child is a little shorter. This one is F3 along Y. F3 has only Y. Does it make sense? Now this becomes just like a previous problem. Meaning, now you have all the forces, isn't it? Now, all you do is, you have AX is this, isn't it? So all you have to do is find out F1X. So what's your F1X? Find out F1X, which is what? 100 of cosine 60. Very good. So this is 50 for sure. This is because this is 1/2, right? Isn't it? 1/2. So 1/2 of 100 is 50 Newton. What about F2Y, F2X, which is 140 cosine of minus 30, right? By the way, cosine of minus will be plus anyway, isn't it? Are you following? So it makes sense because when you look here, x component will be, this also has positive, this also has positive, right? Right? Say it again. Yeah, you can put it, but when you use calculator, it gives positive value anyway. So
121.
technically, it is like angle is negative. So you just like what you have done here.
I'm just saying it doesn't matter.
Doesn't matter, yeah. Here it matters.
Fourth quadrant.
Why it is negative, but
On sine is positive. Fourth quadrant.
right. So okay. So what will be this value?
121.
21 point
21.2.
Newton. Okay. Now what about F3? Do I need to write down
Which one?
F3? F3x. What about F3x?
It's gonna be.
F3x is gonna be 0, right?
Which is cosine of 270.
Because F3x is what? Minus 90, right?
Yeah, it's sine.
Or 270,
Yeah.
right? Whether you do 270 or 90 cosine, that will be 0, isn't it? So your total,
We don't have F3. It's gonna be minus.
so your total along,
How about F3Y?
say it again,
F3Y is minus.
F3y is already there. You don't need that. So total of F along X is what? You just add all of them. 50. Oh, let me use a different ink. Okay, 50 is green. Okay, so it is 50 Newton plus 121.2 Newton plus 0. So this will be what?
171.2.
Which equals what?
171.
1?
171.
150 and 21 will be 71. Of course, 0.2 Newton. So your total force is this. The total force means what? Mass times acceleration. Because the question is asking you what is the mass of the car. So the clue here is, we know the mass is what? Total force divided by acceleration, isn't it? So the acceleration is there, so total force was the clue, right? So your mass equals total force along x by acceleration along x, right?
Yeah.
So this will give what? 171.2 divided by ax is what? What is it? 2 meter per second square. By the way, Newton means what? Meter per second square, right? Kilogram meter per second square. So meter per second square cancel, so kilogram is left here. So this is, can you divide this?
85.6.
85.6 kilogram.
I think
Does it make sense?
So do we have to do it alone? Oh, yeah, X. You don't need this, that X component?
You don't need.
We don't need the Y component?
You don't need it. Yes. Because the question has given you, it goes to the x direction only with 2. Right? Does it make sense? Let me grab one more problem and then we'll wrap up chapter 4, okay?